Hey students, how are you all? I hope you all are doing good. So today is going to be the last lesson of this chapter, electronic devices or the circuit devices. We learned so far many devices, LDR, thermistors, diodes. Today we are going to learn a very new topic. The name of the topic is logic gates. I'm sure it's a very new topic. You haven't heard it before. But you must have heard the word logic. What does logic means? Logic means reasoning, right? When we say that logically it is correct, means there is some reason for something to happen, right? So we are not going to learn about what is inside the logic gates. They are made up of those simple basic devices like resistors and diodes. We are going to learn in IGCSE syllabus only their circuit symbols and how they behave inside a circuit. Now the question arises that where we use it, what is the purpose of logic gate? So when a engineer design a circuit, an electronic circuit, the first thing in his mind is that what the circuit is going to do. What's the purpose of the circuit? What task it's going to perform? Let's say in a calculator, there is a circuitry which can add, right? So when you press the keys, let's say 4 and 7, the answer appears as 11. But if you change the keys press, the answer will be different, right? It will be depending on the input values it has being pressed, right? So inside the electronic devices like calculator, there are such logic gates. Such logic gates perform such operations. Now the main thing is that we know about all this 3, 4, 5, right? But does the electronic devices understand all this 1, 2, 3? No. Electronic devices or any machinery for that matter do not understand this 5, 4, 6. These are the numbers we used in our daily life, right? This number system is called decimal number system because from your preschool you are learning the counting is like 1, 2, 3, 4, 5, 6, right? So there are 10 digits in our daily life counting. It is called decimal number system. But the maths a computer or a electronic device understand is very different. It is called Boolean maths, which is basically binary variables and which has only 2 values, because machines do not understand all these numbers. Machine only understand 2 values. Either there is a voltage applied to them or there is no voltage applied to them, right? So they only consider 0 and 5, and 0 represents this 0 and the 5 voltage, when a voltage is applied to them, it is considered as 1. The same thing in the machinery can occur as either the bulb is turned on or the bulb is turned off. So when the switch is turned on, it means a true condition, and when the switch is turned off, it means false condition. So you understand that machines have different maths other than us. So inside those machines there are logic gates. Logic gates have some input just like your calculator, and based on that input values it produces an output. Okay. For input, I have added over here some switches, and for output, I'm going to show it as a bulb, as a light bulb, which will be turned on or off according to this condition. You can see here with these switches, I can either turn it on and off. So there can be many possible values, right? Either both switches will be turned on or the both switches will be turned off, right? So based on a variety of input values I can apply to this logic gate, we can form a table. This table is called truth table. It actually has all the possible values of input, and based on that value, what will be the output of a certain logic gate is also given in this table. Okay. So as you have learned in maths, probability, that when you flip a coin, either it is head or tail. Similarly, when there are two values, either the value can be 0 or 1, right? So based on that, we have designed a truth table, whether both switches are turned off, whether one of the switches turned on, or both the switches are turned on. So this type of table is called truth table. So this is all about logic gates. Remember in the first slide I showed you 3 diagrams of logic gates, and the title I wrote as logic gate squad, right? Because there are quite a few logic gates which we are going to learn in IGCSE syllabus. Not only these 3, but some combination of these basic 3 logic gates also we are going to learn. So let's start with the very basic one. The very basic or the first logic gate is called NOT logic gate. Its symbol is that similar to that of a diode, a triangle. In front of triangle there is a bubble or there is a circle, but we call it a bubble. In the diode there was a line over here, right? A barrier line. Why it is very basic? Because it has got only one input, and similarly it has got only one output. So as the name suggests, NOT, just like in daily life or in grammar, wherever we add NOT, what it does to the sentence. In grammar we learn when we add NOT, it reverse the meaning of a sentence, right? Similarly here also in electronics, whenever we add a NOT gate, it basically changes the situation. So you can see over here, if the switch is off, the bulb turns on, right? It is opposite to that of the usual case. When it is off, the bulb is also off, right? And when the switch is turned on, the bulb is turned on. So it make the change different, opposite. So it is represented as A bar. In maths also you have learned it, that wherever there is bar, it reverses the things. Like in sets we have set A complement or like that, right? So the output of this gate is represented as inputs reverse with a bar on the top. So as I explained, it reverses the situation. So if we want to write the truth table for this logic gate, let's say when the input is 1, means when the switch is on, what will happen on the output? The bulb will turn off or a 0 will appear, right? And when the situation reverses, when the switch is off, it becomes 1. As you can see, now the bulb turns on. So it only reverses the situation, and its truth table is also very simple. Only 2 conditions, just like coin, either it is head or it is tail, right? So hope you understand it. Let's move on to the next logic gate. Of gate we are going to learn is OR gate. OR gate is a little complex, you can say, just because it has got 2 inputs and it has got 1 output. Let's name it A and B, and let's the output is represented by a plus sign. Like in NOT gate, the output was represented by a bar on the top, right? Here it is represented by a plus sign. So what does an OR gate do? Here in the truth table, I have given all the possible combinations of OR gate. What it does, just like in English, we say the word OR where there are 2 choices or more than 2 choices also, right? For example, if I say if I ask you that give me black or blue pen, I want to write something. What it means? It tells that either blue or black, it doesn't matter, I'm going to write with it, right? So similarly here, this gate will operate this bulb or switch on this bulb when any of the input is high. So you can see over here, when any of the input is high, it will turn on. Also, even if the both inputs are high, that also will turn on the bulb. So you can see over here, A is on, B is off, and the bulb is on. right? But in case if both the inputs will be 0 or will be turned off, then the output bulb will also be turned off. So you understand this OR gate? It works similar to that of word OR. When any of the input is high or even both the inputs are high, then the output will be a high as well. Students, this is another type of gate, AND gate. It is called AND gate. Similar to what we learned for OR gate, how we use the word AND in our daily life. When we need both things or more than two things, right? For example, if I ask you to give me a pen and a notebook to write something, so I need both things. If you give me one thing, let's say pen, and if you won't give me a notebook, I will not be able to write. So if similar to this daily life example, AND gate works when the both conditions are true. So like OR gate, it has got two inputs, namely A and B. The output is 1, which is the symbol of AND gate in Boolean maths is a dot, just like multiplication symbol in normal algebra. And it works only when both the switches are on. If any of the switch is turned off, it will not work. So let's have a look about its truth table. So you can see in the truth table, only when the both switches are turned on, then the output will be on, right? And if any of the input is 0, then output is also 0. So AND is very similar to OR gate, but it is opposite. The output is opposite. You can see over here, if any of this is 0, it turned off. So from these three basic logic gates, NOT, OR and AND, engineers design a very complex circuitry to perform the basic operation, let's say this addition, as we discussed earlier, addition. These gates are used in the circuitry of our calculators and computers, which is very complex. As you can see, 4 and 7 is first converted to the binary equivalence, Boolean equivalence, then 11 is also received as the output of this complex circuit in the form of Boolean. Of course, this circuit is very complex for grade 9 student. So let's take a look on the application of these gates, very simple application of these gates. Okay, so first we are going to learn about NOT gate. Remember in LDR I told you that LDR works in the light condition and in the dark condition it turns off, right? And then I gave you the example of garden lamps where it works opposite, or in the street lamps when it is night time they turn on, and when it is daytime the street lights turn off, right? So in that case this switch can be replaced with the LDR, and the LDR output is connected to the NOT gate, and the NOT gate is that connected to a lamp in the street lamps. So you understand how we use LDRs along with this logic gate to work in opposite condition. Similarly, for example, this OR gate we learned, and I told you that OR gate works when any of the input is high. Let's say that an engineer wants to design a fire alarm. So instead of this lamp, there is an alarm and a bell, an electric bell is over here. So fire alarm works in two conditions, let's say when it detects smoke and when there is high temperature, right? So you may connect the two inputs of an OR gate to a thermistor and to a smoke detector. I hope you remember a smoke detector from radioactivity chapter. So one of the input is connected to smoke detector and one of the input is to the thermistor. So if any of the input gets high, the fire alarm will start working, right? So in that case we use OR gate. Similarly, for example, let's say you don't want to operate like this, your fire alarm, but you want to operate it only when both things happen. For example, you want to put a fire alarm in a kitchen, and in kitchen, you know, there is most of the time a smoke, but the fire condition is not very high, like very dangerous, on the very dangerous level. So you want to operate this fire alarm only and only if a smoke detector and the fire both are in high conditions. Means in normal condition, when it detects a smoke, it should not work. So what an engineer is going to use in that condition? The engineer will use an AND gate. So only when the fire thermistor turns high and also the smoke is detected, then only the fire alarm will work. So you understand the simple application of these circuits? Now, we learned about all the basic gates and they are very powerful, right? You understand that they are very useful. Then comes some complex gates, or the gates which are formed by the combination of these three basic gates. They are NOR, NAND and XOR. First, we will take NOR gate. NOR gate is the combination of NOT gate and OR gate. So that's why the name is also abbreviated from NOT and OR, and it is named as NOR. So what NOR gate does, and you can see the symbol is also very similar, like OR gate with a bubble. Bubble is from the NOT gate, right? And the output is A plus B bar. On the top there is bar. So what NOR gate does, whatever is the output of OR gate, it makes it reverse, because then it is passed through a NOT gate. In an OR gate, what was happening? Let me take you back to the OR gate. In OR gate, we learned that the output is high when any of the input is high, or even both the inputs are high, right? There are 3 ones in the AND and only 1 0 in the beginning when the both inputs are high. But opposite to that, the NOR gate, which is basically A plus B bar, it is opposite. What is happening over here? Let me show you. Over here, you can see these 3, whenever any of the input is high, it becomes 0. And when both the inputs are 0, it is 1. So it is very opposite to that of the OR gate, right? Then let's start NAND gate. NAND gate, similar to NOR gate, it is the combination of AND plus NOT gate. So the symbol is same, AND gate with a bubble on the top, and the output is A dot B bar. Bar means NOT and dot means AND. So in AND gate, the output turns high only when both the inputs are high, right? So it is opposite of that. Now the output is low when both inputs are high, and in the other case, like reverse to AND situation, it turns on. As you can see over here, when any of the input is 0, it becomes 1, it becomes high. Then comes the last type of gate, which is called XOR gate. XOR gate or exclusive OR gate, it's an OR gate with a bar in the start, in the beginning. Its symbol is plus sign with a circle in the surrounding. Word exclusive, X is from the word exclusive. Exclusive, as you may have heard in newspaper, a very exclusive news, right? Means that only that newspaper have that news. Or sometimes some dress designers give some dresses which are very exclusive, means that they are not available for anyone. Similarly, exclusive OR gate operates or turn on this bulb only and only when the inputs are different to each other. See, 0, 1 and 1, 0. When the inputs are same, means both are 0 or both are 1, then it is 0. When the inputs are different to each other, then only it turns on the light bulb, right? Hope you understand the whole topic. And for reference, I am giving the page number of your books in the description box as usual. So you may read this topic from the book also, and you can even copy the truth tables, and you can refer to the diagrams, these circuit symbols from the truth table. Worksheet and notes also will be uploaded to the website. I hope that you will try to attempt the worksheet. Thank you. These gates are